Morning, good morning. Thank you all so much for being here. I have to admit, it is rare that we see this many people out at a 9 a.m. something session the last day of Inforce, even some standing room only in the back. So everybody, thank you all so much for being here. I'm Mike Cornstubble. This is my colleague, John Soul. We're both solutions architects here at Amazon, AWS, and we're here to talk to you about VPN-less access to private services with AWS Verified Access. All right. So what's the need? What's the story behind verified access and why do we need it? Simplify connectivity, right? You all have corporate resources. You all are here right now, so I assume you do remote work. No one's able just to tune out for 3 days. I wish we could. So what does that mean? Usually we either have VPNs, we either have site-to-site VPNs from branch locations, we have client-based VPNs here, but those are network pipes. You know, that involves tunneling, split tunneling, forking network traffic, dealing with IP-based policies, not just layer 7-based policies, right? What else? Maybe we also have direct connections, just like I mentioned, full tunnel VPNs. Let's send all of our traffic one way and hope for the best upstream. But what about granular access control? What about something about policies per apps? An individual application as an individual flow that can be treated as zero trust with verified access. What about access from anywhere? Browser-based or agent-based? Effectively, we're saying zero trust, right? Not just a trusted VPN-like system, but a zero trust-based architecture. So zero trust. When I say zero trust, anybody implementing zero trust today? Show of hands. Hands, zero trust. Nice. Yeah, it's kind of not just a buzzword, but the way of operating right now, and helps us get through a lot of audit and regulatory pain at the same time. So zero trust network access, it's a model that means we effectively don't trust anything, right? We don't just verify access once, like a VPN, where we say password or authentication-based or cert-based auth, and then establish a tunnel. We're always consistently verifying what is this flow, who is it from, and always giving verification. So we use traditional identity sources, like Active Directory, IAM, LDAP, any traditional source, to maintain who identity is. We have a device or an endpoint, and then we continuously verify what that flow to that source is, meaning we always use something like AWS Verified Access to take a look at the requests and evaluate trust on each request, right? So think of that as the opposite of a VPN. On a VPN, a client VPN, we evaluate trust on connection, right? We evaluate trust by AAA on connection. We establish either identity, we've got a cert, we have our AAA, and then we rock and roll. And we only re-authenticate or re-evaluate that trust when we disconnect and reconnect. Zero trust says for every request that we send, let's evaluate trust. Let's figure out who we are, and what we're doing. And on top of that, we can take this to the next level by increasing your mobility, improving your posture, and also simplifying your operations. But what do we mean by that, right? Mobility, when we can access anything from anywhere using zero trust and treating different flows in different ways for policy, which we'll talk about here in a little bit, we can take your workforce and distribute them where you need them to go. Not based on a VPN client compatibility, right? Not based on a desktop endpoint security solution, right? We can put it on whatever device you need to be on. At the same time, we can improve our security posture because we're not just evaluating trust at one point, we're evaluating trust on multiple requests, and we can treat different requests with different policies. And at the same time, we simplify these security operations because what was a thing like VPNs, certificates, policy-based access, IP-based policy, firewall policy, all those things goes away to just be a policy within an AVA endpoint. So what do you mean there? Let's take this example of securing access to some corporate applications. We take AWS Verified Access. We have a policy on a per application basis because each application is a different request, a different layer 7 policy, a different flow, so we can authenticate it and zero trust and treat it that way. We have per app policies that give us fine-grained access control with dynamic authorization, meaning again, every request has that level of AAA to it. We improve our observability because we're not just saying, for example, in a VPN-like world, we're not saying, well, the pipe's up, we've got packets going through it. No way. With verified access, we can say we have observability over every request, every flow for our policies at the application-based level, all layer 7. And we can use your existing security services like identity, trust providers, and multi-factor authentication providers to integrate with Zero Trust and AWS Verified Access to get you where you need to go from your device and your endpoint to your application, no more and no less. So what this means is we first have verified access, we create and configure our trust provider, our group, our policy, and then for each private service, we create an AVA endpoint, a verified access endpoint, that gets us to the TCP protocol and the layer 7 application that we want. And we also have our connectivity client at the edge, which allows us to connect to that, which my colleague John will tell you a little bit more about on how to access private services.
All right. Thank you, Mike. And I'm not dressed quite as cool as Mike, so sorry about that. You'll have to deal with me. I'm John Saul. I'm a solutions architect based out of Atlanta, and I'll be going over how to access two services, FSX for Windows Server and Amazon Open Source Serverless through AVA. So the first, we'll take a look at AVA to FSX for Windows File Server. And in the deployment architecture, what we have is an Amazon FSX server deployed. Now you have three options on how to deploy FSX. You have a multi-AZ for HA use cases. You have the single AZ2, and you have the single AZ1 configuration. So at this point, AVA only supports the single AZ1 configuration and does not support the other two for various reasons. And also, you need to deploy an Active Directory, which authenticates the user when they access FSX. So the flow, going from left to right, will be the user will deploy and launch the connectivity client on the laptop. And then, using the connectivity client, they'll access AVA's, the instance that you define in AVA. And after authenticating against the trust provider, which in this case is IAM Identity Center, the user can then connect to the AVA instance, access the defined AVA endpoint, and then through the endpoint, they can access the FSX server. Now, every request to that endpoint, as Mike said, is evaluated against a CEDAR policy. So only those requests that satisfy the policy are allowed access to the endpoint. So let's take a look at the CEDAR policy that is going to control access to this endpoint. So it permits access to the endpoint when the user has an email address that is from Amazon.com, and the email address has been verified by IAM Identity Center, which is the trust provider that we configured for this use case. So every request is going to be evaluated against that policy, and only those requests that comply with that policy will be allowed access. So to configure AVA, we need some network information from FSX. So first, we need the VPC that the FSX server is deployed to. And we also need the network interface of the FSX server. And once we get that, we go to the AVA console. We deploy or we create a new endpoint. And we configure it so that the endpoint protocol is set to TCP. The VPC is set to the VPC of the FSX server. The endpoint type is set to network interface. There is another endpoint type, which I'll talk about a little bit later in a video. I won't talk about it in this session, but I'll give you a reference to the video. And then the port range, we set to the SMB port of 445. And we set the network interface to the network interface of the FSX server. Now for the security group, we can set the security group to be the same as the FSX network interface, or you can choose a different security group for your AVA endpoint. But if you do that, you just need to make sure that the FSX network interface security group allows access from the AVA endpoint security group. Then we hit submit, and we create the endpoint, and you take the endpoint domain name to connect to the AVA endpoint, and through that endpoint, you'll connect to FSX. So after that, you will go to the laptop and launch the connectivity client. And through the connectivity client, you authenticate against the configured trust provider, which in this case is IAM Identity Center. And after authenticating, you connect to the AVA instance. And then after you connect to the instance, and in this case, I'll be using macOS to demonstrate this. You get the AVA endpoint. You connect using the Finder, using the SMB protocol to the AVA endpoint. And then through the AVA endpoint, you can then connect to FSX. FSX will challenge you with Active Directory, and after authenticating against Active Directory, you can then mount the file share into your Finder, and you'll be able to browse the file share. You'll be able to, depending on the permissions that you're given through Active Directory, you'll be able to drag and drop files into the file share. All right, so in the AVA instance, you can configure access logging. And if you enable access logging, AVA will log all access control decisions into CloudWatch logs. So this is an access log entry for the previous interaction. We can see that the authorization decision is an allow. We take a look at the user information. We see that the user is named John. And John has an email address, which ends in Amazon.com, and it has been verified by the trust provider. So that, in this interaction, it complies with the CEDAR policy that we defined for the endpoint. So this access was allowed. Now, in the privileges field at the bottom, that contains the identification or the ID of the AVA endpoint that this authorization decision was made against. Now, let's take a look at another user. And this user is named John G. And John G is also defined in IAM Identity Center. So he launches the connectivity client on the laptop, authenticates against IAM Identity Center, and then is able to access the AVA instance. Now, after that, John G also would like to access the FSX server through the AVA endpoint. But he experiences a problem. So let's take a look at what might be causing this problem. So we'll take a look at the access log. We see that the authorization decision is a deny. And looking at the user information, we see that the user name is John G, but his email address is a gmail.com email address, which has not been verified. So this does not comply with the CEDAR policy that we defined for this endpoint. So John G is denied access to the endpoint. So it stops right at the endpoint, does not get to FSX at this point. All right, so let's take a look at using AVA to connect to OpenSearch serverless. In this case, it'll be the OpenSearch serverless private endpoint. And when you configure an OpenSearch serverless private endpoint, OpenSearch will deploy a VPC endpoint that it manages, and it will also deploy a Route 53 private hosted zone. And in that private hosted zone, it will create an entry for the OpenSearch endpoint. And we'll see how this comes into play later on. I'll show you in the rest of the or further on in the presentation what implications this has. So taking a look at the flow going from left to right again. So the user will be on the laptop, launching the connectivity client to connect to the AVA instance after authenticating against IAM Identity Center. Then the user will access the AVA endpoint. And through the AVA endpoint, the user will be able to access the VPC endpoint. And through the VPC endpoint, the user will be able to access OpenSearch serverless. So to configure AVA, we need some information from the VPC endpoint. But please note the endpoint on your bottom right. That is the OpenSearch endpoint, and that is what gets put into the private hosted zone, and that becomes a CNAME into the VPC endpoint domain name. So taking a look at the VPC endpoint, we get the VPC information. So we get the VPC that the VPC endpoint is deployed to, and we get the network interface that is associated with the VPC endpoint. Then we create a AVA endpoint, configure it with a TCP, set the VPC to the VPC endpoint, set the endpoint type to network interface, and that's the only endpoint type that AVA will support with OpenSearch serverless. Set the port range to the HTTPS port of 443. Set the network interface to the network interface of the VPC endpoint. And then choose your security group to allow access. Then once we do that, we create the AVA endpoint, and again, use the endpoint domain to connect to the AVA endpoint. And at this point, we will go into the laptop, launch the connectivity client, and then access the AVA instance. This is exactly the same as FSX, so I won't show it. But once we connect to the FSX server, we then need an API client to communicate with open source or OpenSearch endpoint. And since OpenSearch is protected by IAM, each request needs to be signed through AWS Signature v4. Fortunately, Postman supports this natively through its authorization section. So you just set the authorization type to AWS Signature, and then you fill in the AWS credentials. Now, best practice is to use temporary credentials. So you can use something like the AWS CLI to generate those credentials, then fill in the credential information. You set the region to the region that you deploy AVA and OpenSearch. And for the service name, you set that to AOSS, which stands for Amazon OpenSearch Serverless. So let's take a look at what this will look like. So we take the endpoint domain name, and we put that as a host name within the get, within Postman. And this will be a get against the search resource, against OpenSearch. Now notice in the host header is set to the default host header within by Postman. And that is set to the AVA endpoint. So OpenSearch actually can't resolve this request. So it gives you a 404. And that's because OpenSearch is actually looking for the OpenSearch endpoint in the host header. So we have to uncheck the default, create a custom host header, and set that to the OpenSearch endpoint. And once we do that, then OpenSearch will be able to resolve the request, and you'll get back a nice, happy green 200 status. Everyone will be happy at that point. All right, so I went through that relatively quickly. I did create a couple of videos that I published to the AWS channel on YouTube. And yep, I'll give you time to take a picture. So the first goes over AVA to FSX. It covers the network interface that I went over today, but it also covers the CIDR range endpoint type. And the CIDR range endpoint type is great when you have a lot of services within that CIDR range. So AVA will auto-discover those IP addresses, and it'll make all those services available through the endpoint. So it's a very convenient way to expose a lot of services and protect it and make sure you have some zero trust in place there. And the second takes you step by step to configure AVA to access OpenSearch Serverless. All right, well, thank you very much. On behalf of Mike, we thank you for your time. We hope you found this session valuable. And we'll be available off stage here for questions. And have a great rest of the conference.